Hello friends, in this video we will be discussing the Moore machine. Moore machine is again a six-tuple like a Mealy machine as we have discussed in the previous videos. However, the difference is that in Moore the output depends only on the state and not on the input, and therefore the output is attached with a state. And also, since the output is attached with a state, the Moore machine generates an output of length n plus 1 if the input is of length n. That means always the length of the output is going to be 1 more than the length of the input. So let us look at the Moore machine with an example. So Moore machine is again a six-tuple. It consists of the set of states Q. It consists of the input alphabet sigma, the output alphabet delta. Then it consists of the transition table. Then it consists of the output function lambda. And it consists of the initial state. The only difference is that lambda is just a function of the state mapped into the output. So let us take one example. So suppose I have a state Q0 and the associated output is 1. For this, if I receive a value of 1, I will go to the state Q1 and I am going to output odd and say I am going to output even here. So now if I receive a 0, I will remain in Q1. Now if I receive a 1 over here, I am going to reach Q0 and I am going to output even. And here if I have a transition of 0, still the number of ones is even. And if I have an input of empty, still the number of ones is even. And this is my initial state. Now here if I have to make the transition diagram or the transition table, again I will make 3 columns, 2 corresponding to the state, inputs, and so here we can see the states are there. The input alphabet 0, the input alphabet 1, and we also have a null transition, so we will include that. So we have a transition of null, and we have one column for the output which is delta. So now the states are Q0 and Q1. So what we will do is Q0 will always generate an output of even, and Q1 will always generate an output of odd. So this is fixed with the state itself. And now the transitions. So Q0, if it is going to receive a 0 as input, it will remain in Q0. If it receives a 1, it will move to Q1. Then Q1, if it receives a 0, it will remain in Q1. And if it receives a 1, it will move to Q0. And for empty, the Q0, if the input is empty, then it will remain in Q0 and it is not defined here. So this is the transition table for this particular Moore machine. Now suppose we have an input of 1, 0, 0, 1. Then how we are going to proceed? First we receive an input of 1. So for 1 we are going to output. First of all, without any input only, we are going to output even. Then for 1 we will output odd and we will move to the state Q1. Then for the input of 0, in the state Q1, we are going to output odd and we are going to remain in Q1. Then for an input of 0 in the state Q1, again we will output odd and we will print Q1. Then we have a 1 again. For this we are going to output, we will move to Q0 and we will output even. So as we can see here, this first one generated the output odd and the second one generated the output even. and initially the number of ones is even only, 0 means even, so therefore we have outputted even. So this is the output of length 5 for input of length 4. So n is the length of the input, then the length of the output is n plus 1, which is 5 in our case. I hope this video is useful to you, and in the next video we will be doing the conversion from mealy to Moore. Thank you very much.